Hello, boys and girls, and welcome. This is Mr. Mackmin, live on the wire. Today we're going to talk about right angle trigonometry. Some of this will be review, and some of it is new. Okay, so here's your right triangle, and you notice that little theta in the corner. That is called your reference angle. We can use the reference angle to determine the sides based upon it. You have the hypotenuse, which is always, in your right triangle, the longest side, which is across from the right angle. You then use your reference angle to determine the opposite side. As noted by the arrow, it is the side that is across from the reference angle. And the remaining side is the adjacent. Now, the little bit of review, your sine theta, your cosine theta, and your tangent theta all have ratios of, if you remember, SOHCAHTOA. Sine of theta is opposite over hypotenuse. Cosine theta is equal to the adjacent over the hypotenuse, and the tangent of theta is equal to the opposite over the adjacent. Here you see you have a right triangle with a reference angle theta, but you don't have a given side. We're asked to find the value of sine, cosine, and tangent functions for theta. So first off, what we need to do is figure out what is that other side. Well, in geometry, we learned something pretty fun called the Pythagorean theorem. The Pythagorean theorem tells us that a squared plus b squared is equal to c squared. What this tells us is the sum of the squares of the two shorter sides is equal to the square of the longest side. In this case, we have one of the shorter sides, 16, so we're going to place that in for a, and we're going to square it. We know that we have the longest side, 34, is our hypotenuse, so we're going to place that in for c. That's 34, and we're also going to square that. The remaining variable left over could be b. It could be a if you choose it to be. I'm going to choose b, and we leave that squared. Using a fun bit of algebra, we are going to find that we can subtract 34 squared, or rather 16 squared from 34 squared, to give us a total of 900. This will leave us with what the value of b squared is. B squared shall equal 900. Now we want to figure out what b is, because b is the value of the side. So to do that, we take the square root of both b squared and 900, and what you find is that b comes out to 30. Now you have the length of that other side. Pretty basic. If you find that you have a problem like this, this is how you figure out the other side. So I'm just going to erase all of this, and ta-ta, we have our side labeled 30. Now we have a reference angle. We have the length of our three sides. We are going to use that to determine the value of sine, cosine, and tangent. So we take our reference angle, and we're going to, for good measure, label our sides. Hypotenuse, which is the longest side across from the right angle. The opposite side, which is, in this case, 30, across from the reference angle. And the remaining side, adjacent. Now, if you know your basic trig ratios, you should be able to do this simply by plugging in and reducing fractions. That leaves you with sine of theta equal to the opposite over the hypotenuse, which is also equal to 30 over 34. When we reduce this, we get 15 over 17. Cosine of theta can be solved in a similar way using the ratio. The adjacent over the hypotenuse, which is equal to 16 over 34, which itself reduces down to 8 over 17. Running out of room. Note to self. And finally, we're looking for tangent. Tangent of theta. Well, that's easy too, because we know that the tangent of theta is equal to the opposite over the adjacent. We already have them labeled, so it's plugging in. The opposite is equal to 30. The adjacent is 16. This reduces down by factoring out a 2 from both sides, or pardon me, from the numerator and denominator, to 15 over 8. Okay, so here we have reciprocal trig functions. Well, our reciprocal trig functions have very specific names. We have the cosecant of theta, we have the secant of theta, and we have the cotangent of theta. And just as the name infers, these trig functions are reciprocals of the functions that we had before. The cosecant of theta is equal to the reciprocal of the sine function, in other words, 1 over sine theta. The secant of theta is equal to the reciprocal of the cosine function, or 1 over cosine theta, and the cotangent of theta is equal to the reciprocal of the tangent function, or 1 over tangent theta. Similarly, we can say that the ratios are also reciprocals. So, the cosecant of theta is equal to the hypotenuse over the opposite side, the secant of theta is equal to the hypotenuse over the adjacent, and the cotangent of theta is equal to the adjacent over the opposite. Now in this example we have a reference angle and we are given 3 sides. I believe in your example that you are told to find the other side. You can do this using the Pythagorean theorem, which shouldn't be too much problem. Just refer back to example 1 how to do that. I have labeled it 9 here, and now I've labeled the hypotenuse, the opposite, and the adjacent in regards to my reference angle. Now, I'm asked to find the 6 trigonometric functions. Let's start with the basics. Sine of theta, cosine of theta, and tangent of theta. Sine of theta is equal to square root of 5 over 9, or the opposite over the hypotenuse. The cosine of theta is equal to 2 over 9, or the adjacent over the hypotenuse. The tangent of theta is equal to the square root of 5 over 2, or the opposite over the adjacent. Now, we are also asked to find the inverse functions for theta, cosecant, secant, and cotangent. Now, cosecant, we plug in the hypotenuse over the opposite, and this gives us a radical in the denominator. Uh-oh! For those of you who remember from algebra, you cannot have a radical in the denominator. Don't worry, it gets much easier. Just follow along with me. What you need to do is very simple. Take your fraction, 9 over radical 5, and to get the radical out of the denominator, what you need to do is multiply both the numerator and the denominator by the radical part in the denominator. In this case, we multiply by radical 5 over radical 5. When we do this, we end up with, in the numerator, 9 radical 5, and in the denominator, radical 5 times radical 5 gives us 5. Now we have the radical in the numerator and not in the denominator. We have a real number in the denominator, or rather an integer. So, what we say is that the cosecant of theta is now equal to this new number, 9 radical 5 over 5. This is the simplified version, and this is what you will be expected to place. The secant of theta is pretty basic. It is the reciprocal of the cosine of theta. In this case, we have 9 over 2. Cotangent of theta is the reciprocal of the tangent of theta, and we get a value of 2 over radical 5. Once again, we have a radical in the denominator, so we have to take radical action, as my old teacher used to say. We multiply both the numerator and the denominator by the radical portion, in this case radical 5. We are left with 2 radical 5 in the numerator and radical 5 in the denominator. And we get a simplified version, or rather answer, for cotangent of theta of 2 radical 5 over 5. Here we are asked to evaluate each trigonometric function to 4 decimal places. What you need to do first is make sure that your calculator is in degree mode. Press mode, hit the down button 2 times until you see radians, and shift it over to degrees, hit enter. Now you're in degree mode. For the sine of 120 degrees, all you have to simply do is press on your calculator sine, enter 120 degrees, and close the parentheses as I have not done. Hit enter, and this will give you a decimal answer. Round to the 4th decimal place, and you should get an answer of 0.8660. Similarly with cosine, you plug in cosine 48, and you get a decimal answer which you can round to 4 places, 0.6691. In this, we are asked to find the angle with the given trigonometric ratios to the nearest minute and to the nearest 10 minutes. Okay, well, to do this, first what we need to know is what is the value of our angle. To do this, we need to get the angle alone. Now, there are going to be 2 parts to this. How can we get tangent of theta equal to 2.4 into a situation where we have theta alone? Simply put, what we need to do is take the inverse of tangent to both sides. What this leaves us with is a theta that is equal to the inverse tangent of 2.4. To enter this on a calculator, simply hit second tangent, which will give you the tangent inverse, and enter your number 2.4. Hit enter, and this should give you a decimal answer. Now, we're told that we want to find an answer to the nearest minute. Well, what does this mean? Well, similar to the way that a circle is broken up into degrees of 360, a degree is broken up into minutes and seconds. To do this, we're going to need a special mode in the calculator. Use the calculator, hit second, and hit apps. You're going to get a list, and you're going to hit 4. This is going to give you answer DMS, and you hit enter. If you notice, you get a whole bunch of numbers that have come out here. The numbers are separated into degrees, minutes, and seconds, i.e. DMS. Remember, we want to find the angle theta to the nearest minute. Well, finding the degrees is easy enough. Those stay the same. Theta will equal out to 67 degrees. However, we're not quite sure how to round minutes. Well, take a look at your seconds. If your seconds are 30 or more, then you round up. In this case, since the seconds are 46, we're going to round up to the nearest minute, in this case 23. And to denote minutes, you use an apostrophe next to it. In our second example, we're asked to find the given trigonometric ratio to the nearest 10 minutes. Well, we are going to solve this in a similar manner. Take the inverse sine of both sides. This will leave you with theta equal to sine inverse of 0.3465. To do this on your calculator, what you need to do is type second sine, that will give you your inverse sine, and type in your number 0.3465. Hit enter, and this will give you a decimal value. Now remember, we're looking for theta to the nearest 10 minutes. So we need to use our DMS mode, and this gives us our degrees, minutes, and seconds. We're looking to the nearest 10 minutes, so the degrees stay the same. Theta is equal to 20. And now you just have to look at your minutes and say, does that round up to 20 or round down to 10? Well, 16 is closer to 20, so I'm going to say it's 20 minutes. So that concludes today's lesson. I hope you've enjoyed it as much as I have enjoyed trying to create it. Here's a list of things that you should be able to do. If you feel weak in any of these areas, feel free to go back and practice and concentrate on these skills. Until next time, this is Mr. Mackmin signing off. Bye-bye.